Hi everyone, today we are going to deal with more challenging logarithmic practice questions. This is part 2 and a continuation of the video on solving logarithmic equations. Now do check out the earlier part linked in the description below. If you're ready, let's begin with question 1a as a warm-up question where we need to solve the following equation. Now, in order to solve logarithmic equation, we must always ensure that the bases of the log are actually the same. So in this case, on the left-hand side, it is base 3, and on the right-hand side, it is base 9. So let's try to identify the lowest base, which is 3. We can change log to the base 9 to base 3 by using this method. First, we write the base that we want, which is log base 3, and identify a bigger rectangle, which is 6 minus x. Put it on top, over the denominator, log base 3, because that is the base that we want, and we put 9 over here on the bottom, which is the smaller rectangle. Alright, 9 is actually equivalent to 3 square, so that's why we are writing log to the base 3 square. Alright, so the next step is to simplify the denominator. So log to the base 3 is equals to log to the base 3, 6 minus x, over log base 3, 2, and this will be equals to 2. Alright, and if we bring 2 to the left-hand side by cross-multiplying to remove the denominator, we will have 2 log to the base 3x is equals to log to the base 3, 6 minus x. By engaging or employing the power law, we have log to the base 3 x squared equals to log to the base 3, 6 minus x. Our objective here is to make sure that the coefficient in front of the log is 1 and that the bases are the same. And by doing so, we can straight away employ this comparison method. So therefore, by comparing both sides of the equation, we will have x squared equals to 6 minus x. X squared plus x minus 6 is equals to 0. By factorizing this quadratic equation, we will have x minus 2, x plus 3 is equals to 0, and x is equals to 2, or x is equals to minus 3. Now, if you see a negative value in the answer, make sure you do substitute it back into the original equation so that you can test whether the expression is valid. Now, in this case, log to the base 3 minus 3 is invalid. Therefore, we reject the value of minus 3. Alright, so let's move on to something slightly different. We have log to the base 2x is equals to 16, log to the base x, 2. You realize that the bases are different as well. So what I'm going to do is to convert that base x into a base of 2. Let's write it as log to the base 2x is equals to 16. We want the base 2, so therefore we write log to the base 2, put the bigger square on top, which is 2, over log to the base 2, the base that we want, and the smaller square below, which is x. What we can do next, very simply, is to multiply both sides of the equation by log to the base 2x. Now this will give us log to the base 2x, include a bracket, power 2. And this is equals to 16. Because log to the base 2 is equals to 1. Now do note that this square cannot be brought down as a power law because log to the base 2x is multiplied with log to the base 2x. They are two terms multiplied together. So we cannot bring the power 2 down using the power law. Alright, what we can do, however, is to square root both sides. Alright, so log to the base 2x is equals to 4, which is square root 16, or log to the base 2x is equals to minus 4. Solving the equation on both sides, we have x is equals to 2 power 4. Now, how 2 power 4 came about was from the conversion from a logarithmic form to an index form. Alright, what we do is to take that base 2, push it to the right-hand side, and push the value of 4 into a small power. So it is x equals to 2 power 4. That is how we can convert to an index form. This is equals to 16. Similarly, on the other side, we have base 2. Bring that base 2 to the right hand side. Shift up minus 4 into a power. We have x is equals to 2 power minus 4. And x is equals to 1 over 16. Now, if you are still not sure of how we can approach such question, part C will help to solidify your understanding. We have log to the base 2x plus 2 is equals to log to the base x 2. Now you notice that the bases are different. So intuitively, what we do is to change the base x into a base 2. So log to the base 2x plus 2 is equals to 8 log to the base 2 over log to the base 2x. Now, I do not like a denominator having log to the base 2x. What I'm going to do is to multiply both sides of the equation with this expression. So on the left-hand side, we will have log to the base 2x squared plus 2 log to the base 2x. At the same time, I'm going to bring over the 8 to the left-hand side, which is minus 8 equals to 0. Now, I hope you can see a pattern over here. This looks exactly or similar to a quadratic equation. So what we can do now is to let y be equals to log to the base 2x. And by doing so, we can convert it into y squared plus 2y minus 8 equals to 0. Factorizing this expression, we will have y minus 2, y plus 4 is equals to 0, y is equals to 2, or y is equals to minus 4. Take note that this is not the final answer because we want to find the value of x and not y. So by substituting it back, log to the base 2x is equals to 2. And in order to find the value of x, remember, we need to convert this into an index form. So take that base 2, bring it to the right hand side, push up the value of 2. We have x is equals to 2 squared and is equals to 4. Similarly, we have log to the base 2x is equals to minus 4. X is equals to base 2 power minus 4. And this is equals to 1 over 16. Now we are going to use the same substitution method in part D. We have 3 log to the base 4x plus 2 log to the base x4 equals to minus 5. I'm going to convert log to the base x into a base 4. So this is what I will have. 3 log to the base 4x plus 2 log to the base 4 over log to the base 4x is equals to minus 5. Similar to the previous part, we are going to multiply every term by log to the base 4x so that we can have an expression without any fractions. So this will give us 3 log to the base 4x. The whole thing must be squared plus 2 because log to the base 4 is 1 and is equals to minus 5 log to the base 4x. Let's rearrange this equation to give us 3 log to the base 4x whole thing squared plus 5 log to the base 4x plus 2 is equals to 0. At this point, it resembles a quadratic equation. So let y be equals to, you guessed it correctly, which is log base 4x. So 3y squared plus 5y plus 2 is equals to 0. Solving for this equation, by factorizing it first, we have 3y plus 2, y plus 1 is equals to 0. Y is equals to minus 2/3 or y is equals to minus 1. Now don't stop here yet because this is not the final answer. So log to the base 4x is equals to minus 2 over 3. Converting this to an index form, x is equals to 4 to the power of minus 2/3. And if you would like to simplify it further, it is actually 2 to the power of minus 4 over 3. Similarly, log to the base 4x is equals to minus 1 and x is equals to 4 to the power of minus 1, which is equals to 1/4. Now part E is slightly different. It seems challenging, but the concept is the same. We are going to practice and reinforce the concept of converting a logarithmic form into an index form. All we need to do is to bring up the base 3 to the right hand side to give us log to the base x8 is equals to 3 power 1. Converting one more time to an index form, we will have 8 is equals to x to the power of 3. What we can do now is to convert 8 into 2 power 3 so that we can compare both sides of the equation. And you can see quite obviously now that x is equals to 2. Now let's move on to question 2, where we can employ the concepts of the product law or the product rule, alright, of logarithm So if log to the base 4p is equals to this expression over here, we're going to find the exact value of p. Firstly, all we need to do is to ensure that the bases on every term in the log are the same. In this case, it is base 4, except for the last one. So what we can do is we could put log base 4p equals to log to the base 4, 2 power 3, I'm going to bring up the 3 at the same time, plus log to the base 4, 6, minus half log to the base 4, 4, because this expression is equivalent to 1, which is equivalent to half. Alright, so log to the base 4p is equals to log to the base 4, 2 power 3 multiplied by 6 by using the product law, minus log to the base 4, 4 power half. I'm using the power law for this. Alright, so the next step will be log to the base 4p is equals to log to the base 4, 48, minus log to the base 4, 2. Simplifying further by using the quotient law, we have log to the base 4p is equals to log to the base 4, 48 over 2. And now by comparing both sides of the equation, the value of p is equals to 48 over 2, which is then equals to 24. Now let's try out this third question in the final part of our practice together session. Alright, so given that log to the base 5x minus 39 is equals to 2, we are going to find the value of log to the base 2x. Now some students may approach this question by changing the base to base 2 immediately, but you realize that this doesn't give you quite an exact value. What we can do is to employ the concepts of converting a logarithmic form into an index form. So what this means is that log to the base 5 x minus 39 is equals to 2. Bring that base 5 over to the right hand side and push up the 2 as a small power, which is 5 power 2. This will be x minus 39 equals to 25. Now by bringing 39 over, we have x equals to 64. Now this is not the final answer because we want to find the value of log to the base 2x. So let's substitute 64 into x. We will have log to the base 2x equals to log to the base 2, 64. And this is equals to log to the base 2, 2 power 6. And by using the power law, we can bring down 6. And log to the base 2 is equals to 1. And the exact value of log to the base 2x is equals to 6. Now I do hope you have learned something from this video. Do go through it one more time to solidify your understanding, and do hit that subscribe button so that you can see more valuable content such as these. I'll see you in the next video, and thank you so much for watching.